Today I'll be discussing all the algebra and number questions which were asked in CAT 2021 second slot. Here goes the first question. It is of logs. So as you can see, I'll just write the question again. It's log base 2 a square bracket 3 plus log base 3 a curly bracket. Then we have 4 plus log base 4 a simple bracket x minus 1 and all the brackets are closed. Minus 2 is equal to 0. All right. In the first step, we can send this minus 2 to the right hand side. It will become plus 2. And if I remove this log from here, this 2 will be the base of it. So we'll get 2 to the 2 square. 3 plus log base 3. 4 plus log base 4. X minus 1. Bracket close. So as I said, if I send this minus 2 to right hand side, I'll get plus 2. And then this log 2, if I remove, we'll be having 2 square. All right. The second step now. Let us send this 3 to the right hand side, and that is how we'll get 4 minus 3, that is 1. Now, if I remove this log, this 3 would be acting as a base to 1. That means we'll be having 4 plus log x minus 1 base 4 is equal to 3 to the power 1, that is 3. All right. Then if I send 4 over there, this becomes 3 minus 4 is minus 1. And if I remove log, I'll get x minus 1 as 3 minus 4, which will be raised to power 4. So this is very basic, like sending 4 there, 3 minus 4, then this log, if you remove, the 4 will be acting as a base to the right hand side. Now we'll be having x is equal to, this is 4 to the power minus 1, or we can say 1 by 4. So plus 1 is 1 plus 1 by 4. This will be equal to, x will be equal to 5 by 4. And the question asks about the value of 4x. So if you multiply 4 with 5 by 4, you'll get 5 as the answer. This was an easy question just based on the properties of log. And the property was very simple. It's basically definition of log. So if someone says log b base a is equal to c, that means b is equal to a to the power c. We have used only this definition of log and we have solved this question, which is actually easy, and I will rate this question as easy, as I said, and the idle time that should be taken to solve this question is 45 seconds. Not more than that. The next question. Consider the pair of equations x square minus xy minus x is 22 and y square minus xy plus y is 34. If x is greater than y, then x minus y equals what? So let us do one thing. As you can say, the equation is x square minus xy minus x is 22, and we also have y square minus xy plus y is 34, and we need to find the value of x minus y. Wow. So if you look at this closely, there's one thing that we can do. This minus x and plus y, so it's kind of, if we reverse it, we'll get x minus y. So what I feel that these two equations should be basically added. So if we add them, what do we get? We get x square plus y square minus 2xy minus x plus y is equal to 56. And we always have to remember that to find the value of x minus y. Now, if you look at this, this is nothing but square of x minus y. And this one, if I take minus 1 common, I'll get x minus y inside the bracket. And this will be equal to 56. All right. Now, taking x minus y common from both the brackets, I'll get x minus y common. So it will be x minus y one time from this bracket, as it is a square, then minus 1. This is equal to 56. To find the value of x minus y. So as you can see, that these two brackets which we have now, this x minus y and this x minus y minus 1. So this one is basically 1 less than the previous bracket. So if we break the right hand side into two factors which are just consecutive, like one is one less than the other, so that will be equal to 8 into 7. It's as simple. 56 can be broken down as 8 multiplied by 7. If we compare both the terms, I'll get x minus y as 8 and x minus y minus 1 is 7. So we have kind of obtained our answer, and this is equal to 8. Again, I'll rate this question as moderate, and the time taken to solve this question should be close to 30 seconds. All right. Let's mark option 1 and move ahead. Here comes the next question. Three positive integers x, y, and z are in arithmetic progression. If y minus x is greater than 2 and x, y, z is equal to 5 times x plus y plus z, then z minus x equals what? All right. So when in arithmetical progression, what does that mean? That y is basically the average of x and z. So I can say that 2y is equal to x plus z, since they are equally distributed. All right. Now we have one more equation, this one, which is x, y, z is equal to 5 times x plus y plus z. Now, from this equation, we can replace this x plus z by 2y. So we'll be getting 2y plus y is 3y. So this will be equal to xyz is equal to 5 multiplied by 3y, that is 15y. And y can be cancelled from both the sides because y is not 0. I'll just write it here. Since y is not equal to 0, it is given in the question itself, positive integers. That means we can cancel out y and we get xz is equal to 15. So to solve this, we'll be having like two kinds of values. Either x can be 1 and z can be 15. That is one of the possibilities. Other is x is 3 and z is 5. That is one more possibility. And we have to find out the value of z minus x. There's one more condition given, that y minus x is greater than equal to 2. Greater than 2. So what we have obtained over here, like the value of x is 1 when z is 15, and the value of x is 3 when z is 5. From these two, we have obtained this. We get the value of y as well because we know here that y is basically the average of x and z. So here the value of y will be equal to 8. 1 plus 15 is 16, average is 8. 3 plus 5 is 8. The value of y will be 4. So we have these two possibilities. Now it says y minus x is greater than 2. So if I assume this possibility, y minus x, 4 minus 3 is 1, it's not greater than 2. That means the second possibility doesn't hold true. And similarly, the first possibility, 8 minus 1 is 7, this actually holds true. Now, what does that mean? That x is equal to 1, y is equal to 8, and z is equal to 15. We have to find the value of z minus x, that is 15 minus 1. We can say 14 is the answer. And we'll mark third option and just move ahead for the next question. I'll rate this question as moderate, and ideal time taken should be 60 seconds. Here comes the next question. For a 4-digit number, the sum of its digits in the thousands, hundreds, and tens place is 14. The sum of its digits in the For a 4-digit number, the sum of its digits in the thousands, hundreds, and tens places is 14. The sum of its digits in the hundreds, tens, and units place is 15. And the tens place digit is 4 more than the units place digit, then the highest possible 4-digit number satisfying the above conditions is what? All right. So it's a 4-digit number basically. The sum of thousands. So basically we can have, 4 placeholders. There are 4 placeholders and we can put in the values here. Thousands, hundreds, and tens places 14, and hundreds, tens, units is 15. It's also known that tens places 4 more than the units places. So we can do one thing. Let us assume units place to be A. So tens will automatically be A plus 4. All right. This is something which we have already obtained. Now it's also known that sum of digits at thousands, hundreds, and tens is 14. This is 14 basically. And at the same time, it's also known that digits in the hundreds, tens, and units. That means this hundreds, tens, and units. This sum is basically 15. Now, what does that mean? That simply means that this place, the place at units, this units place will be 1 more than the thousands place. I hope that is understandable, because these two are common in the sum, like in these 3 and in these 3. These two things are common, and sum of these 3 is 15. These 3 is 14. That means this place is basically 1 more than the place at thousands, digit at thousands. So we can write this as A minus 1. All right. So we have kind of obtained a lot of values over here. Now we have to find the highest possible 4-digit number satisfying the above condition is what? So as you can see here, the third place is A plus 4, and any digit cannot be more than 9. So what if I put A as 5? Why? Because if I put A as 5, this will become 9. So let us see what we obtain over here. If I put A as 5, this will be 5 minus 1, 4. Let this be blank. A plus 4 is 9. We will not go beyond this, and A is 5. So now look at this. 9, 5, and 4. We have to put in, just think about the second digit. It has been said that thousands, hundreds, and tens sum is 14. So 4 plus 9 is 13 already. If I put 1 here, I'll get 4 plus 1 plus 9 is 14. And similarly, 1 plus 9 plus 5 is 15. So both the conditions are satisfied. And our answer is 4195. There's a possibility that people might take 4 different variables. Like I have seen people taking A, B, C, D over here. And that is how they will end up wasting a lot of time. This question, if you see here, can be solved in exact 60 seconds. And that's a far-fetched time that I have said. If you start taking A, B, C, D or PQRS, in that case, you will be writing at least 5 steps and wasting 2 to 3 minutes of your precious lifetimes. Do not do that. This is the ideal thing to do, and this is the ideal method to solve this kind of question. Hope you enjoyed this solution. Next question. Suppose one of the roots of the equation x squared minus bx plus c is equal to 2 plus root 3. A, b, and c are rational numbers, and a is not equal to 0. If b is equal to c cubed, then mod a equals what? So let us rewrite the equation. We have ax squared minus bx plus c is equal to 0. It's also given that 2 plus root 3 is one of the roots. And a, b, c are rational. A is not equal to 0, and b is equal to c cubed. So let us do first thing. We can replace b with c cube. That is what we have already. Moreover, there's a rule that when the coefficients of a quadratic, which is a, b, and c, they are rational, then the roots, if one root is an irrational surd, the other root would automatically be its rationalizing factor, that is 2 minus root 3. So if one of the roots, let's say that is alpha, is 2 plus root 3, automatically beta will be 2 minus root 3, its rationalizing factor. That is the only way the coefficients can be rational. Okay, so now as we know it, alpha plus beta, the value will be minus b by a. Here, if you look at the equation, this equation, then it's not essentially A, B, and C. Here B is minus C cube, A is A, and C is C. All right. So alpha plus beta should be equal to minus of the coefficient of x divided by the coefficient of x square. That will be equal to C cube whole upon A. All right. And if we put the values like alpha plus beta, if I add them, I'll get 4. That further means C cube by A would be equal to 4. Or we can also say C cube is equal to 4A. All right. Now, if we multiply the roots, we'll get C upon A. That is C by A. And if I multiply 2 plus root 3 into minus root 3, I'll get 2 squared minus square of root 3. That is 4 minus 3, or we can say 1. So C by A would be equal to 1, or we can also say C is equal to A. Now we have two different important results with us, where C cube is 4A and C is A. This C is A. If I write this to be C cube, if I take cube on both the sides, I'll get C cube is equal to A cube. Now I can equate. As you can see, the left hand side is C cube in both the equations, and right hand side is 4A and A cube. So let us equate A cube and 4A. Then we'll get A cube minus 4A is equal to 0, or taking A common, we'll get A square minus 4 is equal to 0, or we can also say, break this down as A plus 2 and A minus 2, and A, this will be equal to 0. Or now we can say that the value of A is either 0 or minus 2 or plus 2. But in the question it is mentioned clearly that A cannot be equal to 0. Therefore, we will eliminate the case where A is 0, and we'll choose the cases where A is minus 2 or plus 2. These two cases have to be chosen. The question talks about modulus of A. So the modulus of A will be like modulus of minus 2 or plus 2 would be 2 only. That is our answer. I'll rate this question as of moderate difficulty level, and the time taken to solve this question should be 60 seconds. Sequence of real numbers x1 till xn. If x1 minus x2 plus x3 till minus 1 to the power n, n plus 1, xn is equal to n square plus 2n. For all natural numbers n, the sum of x49 plus x50 will be what? So in this question, it's a sequence series question. There has to be a pattern. So first of all, let us try to find the pattern. If I want to calculate x1 only, then this will be, as you can see here, the value of x1 would be n square plus 2n, that is 1 square plus 2 multiplied by 1, or we can directly say 3. This is the value of x1, right? Because n is 1 over here. Then if I take simultaneously two elements, x1 minus x2, as we're going till 2, then n square plus 2n will be 2 square plus 2 multiplied by 2. That is 8. Now by using this, we can calculate the value of x1 and x2 both. x1 is 3 already. x1 is 3 already. That means the value of x2 would actually be equal to x1 is 3. This will be equal to minus 5. All right. So x1 is 3 and x2 is minus 5. Let us try to find out the value of x3. For that, we'll take 3 elements, x1 minus x2 plus x3. That has to be equal to 3 square plus 2 multiplied by 3. That comes up to be 9 plus 6 is 15. And now by using the value of x1 and x2, we'll get the value of x3. So if I put x1 3 and x2 minus 5, I'll get 3 minus minus 5 is plus 8. This will be 8. And value of x3 will be 15 minus 8, that is 7. Now, I think a pattern is quite observable. If you look at the pattern, here we have 3, then we have minus 5, then we have 7. So basically, it is the pattern of odd numbers. 3, 5, 7, 9, and so on. And the signs are getting changed, plus, minus, then minus, and so on. But just to be sure this pattern is right or not, let us calculate one more value till 4. So we'll be getting x1 minus x2 plus x3 minus x4 is equal to 4 square plus 2 multiplied by 4, 16 plus 8 is 24. If you put in the values of x1, x2, and x3 here, I'll get the value of x4. Let's put the values. 3 minus minus 5. 3 plus 5 is 8 plus 7 is 15. 15 goes there. This becomes 24 minus 15 is 9. As we have minus here, the value of x4 will be minus 9. So, all right. So, whatever pattern we discussed, that is correct. It's basically the pattern of the series of odd numbers with the signs being alternately arranged plus, minus, and so on. So, if now we have to find the general term, what that will be. So, as you can see, if this is 1, this is 3. If this is 2, this is 5. That basically means xn, the value, the odd number will be n plus. Here we have 1, then we have 3. So 2 becomes 5 and 3 becomes 7. This will be 2 times n plus 1. So now look at this. If you put n as 1, you will get 3. If you put n as 2, you will get 5. N as 3, you will get 7, and so on. But for the alternate arrangement of negative and positive, we'll just do one more thing. I'll just write minus 1 raised to power n. Why? Because if the power of minus 1 is even, we should get a negative number. So this has to be not n, it has to be n plus 1. So this is how you can kind of look at the numbers, look at the pattern, and minus 1 to the power whatever is there. It depends on like the even power of minus 1 give a positive and the odd power will give a negative. So as we know that the even powers are giving a negative value. So if I put 2 over here, 2 plus 1, 3 becomes odd. So minus 1 power odd is minus. Similarly, if you put 3, x3, you will get 7. And 3 plus 1 in the power becomes 4. Minus 1 raised to power 4 is positive. So we will get a positive value of 7. Therefore, this is the general term. Now we have to calculate x49 plus x50. Let us do that. x49. Let us put in the value. So we'll get 2 into 49 plus 1 minus 1 raised to power 49 plus 1, that is 50. Plus, now for x50, we will get 2 into 50 plus 1 and minus 1 raised to the power 51. So here you will get 98 plus 1 is 99 and power is even. So we'll get 99 positive. And here 2 into 50 plus 1 is 101. It's negative, so minus 101. That is equal to minus 2, and that is our answer, option 2. I'll rate this question as difficult, and because a lot of calculation, time taken should be 120 seconds. Hope you enjoyed the solution. It's all about pattern recognition. For all possible integers n satisfying 2.25 is less than or equal to 2 plus 2 to the power n plus 2 is less than equal to 202. The number of integer values of 3 plus 3 to the power n plus 1 is what? So to solve this question, let us first of all write the expressions. Now here I can subtract 2 from everything, So I'll be remaining with 0.25 is less than equal to 2 to the power n plus 2 is less than equal to 200. Now as you can see, these are the powers of 2 and 0.25 is nothing but 1 by 4. That means this can be written as 2 to the power minus 2, and 200 is something which doesn't lie in any power of 2, but something which is less than 200 and lies in the powers of 2 is 128. That is 2 to the power 7. So basically from 2 to the power minus 2 till 2 to the power 7, this inequality will be satisfied. But here we have the power of 2 to be n plus 2. That means if n plus 2 is minus 2, the value of n will be minus 4, and here it will be 5. That means the values of n can range from minus 4 to 5. All right, so this is something which we have already obtained. Now looking at the second part of the question, 3 plus 3 to the power n plus 1 should be an integer. That means this 3 to the power n plus 1 cannot be a fraction. So the least integer value would be 3 to the power 0, that is 1. So 3 to the power n plus 1 will be 0 only when n is equal to minus 1. Now what does that mean? From this range, that is from minus 4 to 5, minus 4, minus 3 and minus 2 won't satisfy, because if you put that, then 3 to the power n plus 1 will be a fraction, but here they are talking about the integer values. So we'll be having minus 1, 0, 1, 2, 3, 4 till 5. So overall, we'll be having 7 such values. I'll rate this question as moderate. The time taken to solve this question should be 60 seconds. Tell me in the comment section how much time did you take and was it correct or not. All real values of x, the range of the function x square plus 2x plus 4 whole upon 2x square plus 4x plus 9 is what? Okay, so let us write the function again. I can write fx is equal to x square plus 2x plus 4 whole upon, it says 2x square plus 4x plus 9. All right, 2x square plus 4x plus 9. If you look closely, you can see that the denominator is 1 more than twice the numerator, isn't it? So we can do one thing over here. We can just say let a is equal to x square plus 2x plus 4. If I assume this, now what happens? The function will transform into a upon 2 times a plus 1, right? Twice of this is 2x square plus 4x plus 8. This is 9, 1 more than it. So this is what we have obtained already. Now our question becomes really easy. All right, so we'll have to, first of all, we want the range of the function. Now, for the range, we need the minimum and the maximum value of fx. All right, now how to do that? Minimum to maximum. So if we look at this, and also x is real, that is something which we have to keep in mind always. So the minimum value of a, if I find, then I'll get the minimum value of fx by putting the value of a in this function. Now to find the minimum value of a, we'll have to look at this expression, and I'll just use another ink to find the minimum value of a. So minimum value of a will be equal to what? As you can see that x square plus 2x plus 4 is a quadratic expression, and any quadratic expression is basically of the form ax square plus bx plus c, and its minimum is obtained at x equal to minus b by 2a. So here b is 2 and a is 1, so minus 2 upon 2 is minus 1. So if I put x as minus 1, I'll get the minimum value for a. Let us do that. A will be equal to minus 1 whole square plus 2 times minus 1 plus 4. Now this will be equal to 1 minus 2 plus 4. 1 minus 2 is minus 1 plus 4 is 3. So the minimum value for a is equal to 3. Now our question is actually solved. So how beautiful is algebra? You can just, kind of feel it and observe it, how beautiful this becomes. We just have to observe, the first thing that we observed, that denominator is 1 more than twice the numerator. And after that, we did this, we used common knowledge that the minimum or the maximum of any quadratic expression, any quadratic equation, any quadratic function lies at minus b by 2a. And it is minimum when coefficient of x square is positive, and it is maximum when coefficient of x square is negative. Here, it is positive, as we can kind of see here. The coefficient is 1. 1 is a positive number. So we have obtained the minimum already. If I put a as 3, I'll get the minimum value of this function. Let us do that. So at a is equal to 3, the value of fx will be 3 upon 2 into 3 plus 1, that is 3 upon 7. Now we have to find the maximum value. For maximum, what we can do. All right. Now let us use common sense. Let us use your mathematical common sense, I would say. So if I keep on increasing a, for example, if I put a as 1, I'll get 1 upon 3. If I put a as 2, I'll get 2 upon 5. If I put a as 100, I'll get 100 upon 201. If I put a as 1000, I'll get 1000 upon 2001. So I just want to show you something very beautiful about algebra over here. As I said, if I put a as 1000, at a is 1000, the function becomes 1000 upon 2001. If I put a as, let's say, 10 to the power 6, 10 to the power 6, I'll get fx is equal to 10 to the power 6 upon 2 into 10 to the power 6 plus 1. So if you can look at these values, all these values are very close to 1 by 2. This is slightly less than 1 by 2. This is slightly less than 1 by 2 because this plus 1 doesn't really matter if the value of a is huge, large. So if let's say if I put the value of a as 10 to the power 100, something like that, then 10 to the power 100 upon 2 into 10 to the power 100, and this plus 1 would be negligible. It won't be making any sense. So, but whatever happens, this value will try to tend towards 1 by 2, but it will never reach 1 by 2. That means if you look at the options now, if you look at the options, the minimum value is 3 by 7 that we already have. We have two options here like that. And as I said, the maximum value will try to touch 1 by 2, but never touch 1 by 2. So if you look at this bracket, this is open interval and this is closed interval. So 3 by 7 is included while 1 by 2 is not included. That is why option C is the correct answer. This question I would rate as difficult question. But at the very same time, if you know your concepts really well, you can do this really beautifully. So difficult is the level, and time taken should be close to 1.5 minutes, or we can say 90 seconds.